The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Good morning, everyone. I'm here to talk about the latest document, or the first document that has come out of our relatively new BIM committee, and that's the Information Delivery Manual for Cast-in-Place Concrete. The document's been approved by TAC a while ago. You can buy it down at the bookstore. For a new committee, that's pretty exciting. Pete as the chair and me as the secretary, we think we have deserve a break now, but unfortunately there's always more work to do. So what is this IDM thing that Chuck has mentioned briefly, and I'm going to talk about? It's an information delivery manual that summarizes our industry, and our industry, as we consider it for this, is cast-in-place concrete. So we need to understand the construction processes, what actually goes on in our industry from design all the way through completion of construction. And primarily we're interested in the information flow that supports these construction processes. So who's providing what information to who at what point in time. And we're looking at this from the viewpoint of the people actually in the industry. So the software guys are involved in this construction of the IDM, but their viewpoints are not nearly as important as the actual people who are receiving and sending the information. Over a period of a little more than a year, we had day-long meetings at various locations across the country. Had a lot of industry expertise here. You can see listed up there. As well as Chuck was there as our facilitator and IFC expert. And have to acknowledge the PanCow Foundation, who provided a lot of funding for this, and without them it wouldn't have actually come together. The process map you can see here, it's very small. Chuck showed it briefly, but basically it's if you had to take our new document and isolate it or boil it down to one page, that would be the entire document. So we're summarizing our industry, everything that goes on in one chart. You don't realize how complicated your industry is until you try to explain it to somebody who's trying to document it. But we, over a period of a number of sessions, I think we did a pretty good job, and we have the basics of our industry encapsulated in this particular chart. So time goes from left to right on the chart. Each player, each entity in a construction process has what we call a swim lane, which is basically a strip from left to right. And between those swim lanes are these regions where we document the information that's passed between the players in the construction process. Looking kind of up close at the chart, this is the upper left-hand corner. You can see time again is going left to right, and here we have the architect's swim lane and the engineer's swim lane. In between is this exchange data. Need to note that even though this exchange data here is listed between the architect and the engineer, some of this data is actually going to different parties. You can see these dotted lines going off this excerpt of the chart. We're documenting tasks here, so there's a task, I think this is maybe structural design, that is creating information, and then we're documenting the models that pass back and forth between the different entities, and then some non-model exchanges to complete our picture of what's going on in the industry. For tasks, we try to document for each of the tasks what actually is going on in a summary form. This concrete structural design task is excerpted straight from the document. So we're interested in, when the task is occurring, who's actually doing it, what information is required to do this task, and what information is produced by this task. Similarly, the model exchanges, these are, in a sense, the most important thing for us. But we need to know when the exchange happens in time, who sends the model, who receives the model, what's in the model, and most importantly, the level of detail. Obviously, when you get information from your structural engineer on rebar, it's very different than information when you get from your rebar detailer. So that level of detail changes in each different exchange. We also document the non-model exchanges. This is primarily just to kind of complete our understanding of the process. Perhaps some of these non-model exchanges will get incorporated into models at some point in the future, but short term it's just there to make sure we understand the full process. So what good is all this? We've got these tasks, models, non-model exchanges. What are we going to do with them? Primarily they're there for us to look at the model exchanges, and so that we can define standard versions of these exchanges. And standard exchanges have a similar role to other standards in our industry, in that they're there to foster productivity. You can imagine in our industry, if we didn't have a standard test for concrete strength, every time you got a cylinder break, you'd have to go through a long, laborious process to find out what the testing lab actually did, so that you could interpret what the results that came out of the testing lab. So in some sense, these standard exchanges provide this similar productivity as having standard tests and that kind of thing in our industry. Let's look a bit at standard versus non-standard exchanges. Here we have a non-standard exchange, and we have 4 different software products, A, B, C, and D. And you can see there's 6 variations of the exchanges for every pair of products. That actually would be 12 if we looked at going both ways between the products. And the non-standard exchanges are not all bad. The one big benefit of a non-standard exchange is you can take any pair of products and you can optimize your exchange for that particular pair of products. The downside is that there's just way too many cases here for the software vendors to support. So chances are, if you have product set A and C, your software vendor might not have thought that was the most important exchange, so maybe it's not supported at all, or maybe it's supported poorly. So the non-standard exchanges become very difficult to maintain in an industry that has lots of different software products like our industry. Standard exchanges, we still have the 4 products, but we only have 1 exchange. So each software vendor can concentrate on making this 1 exchange work very well. So we have a small number of cases for the software vendors to support. Predictability for the actual end users. If you have software package A here, you know how your software package works with this single exchange, and no matter what other product you're exchanging with, your package always works the same. Potential downside here is the risk of dumbing down the exchange so that it is kind of the least common denominator between all the packages, and in our work we need to try to avoid that risk. So we still, although we're talking about standard exchanges, there's still 24 exchanges on the table. So how do we tackle these exchanges? Well, one at a time. And to do that, we formalize each exchange. So we need to standardize the contents much more than what you saw in those small descriptions there. Standardize the format and add a lot of detail. And once we add all that detail, we have a different model we call a model view definition. And this is something that the software people can start to work with because it's so detailed, it really specs exactly what the software people need to do. So currently we're focused on 3 of these exchange models, or MVDs, with the highest value for our industry. The first one is the structural design model. So the idea here is that we take as much as we can that's currently in plans and specs that come from the structural engineer and convert that into a model. The challenge here for us is that structural drawings, plans and specs, they're not really model-related information, so to speak. They're not really defining physical entities quite so much. It's more a set of parameters and set of instructions to the contractor for the contractor to put together and figure out what the physical entities are that need to be constructed. The other challenge we have is that we can't, in our industry, push the structural engineer too far, turn him into a detailer. In other countries around the world, the structural engineer is the detailer, but in our country here, the structural engineer's scope does not include detailing. We have EM15, which is the detailed rebar model. It's coming from the rebar detailer. This one is a much more physical model showing all the rebar in space. Some of the challenges here are what information we put in the model. Rebar in general, because there are so many pieces in a project, cause problems for BIM software. Just because it overwhelms the software. So we have some challenges on size versus flexibility here. We have a situation where we want to move one bar 2 inches to avoid a pipe sleeve or something like that. We have to have a strategy on how to document that within the format that doesn't cause the format to blow up and become unwieldy in the software. We also have a challenge on some nuclear needs versus non-nuclear needs. We want to make this work for the nuclear industry as much as we can, but we don't want to add so much overhead and difficulty to the spec that it becomes a barrier to adoption for the software vendors or the commercial parties. The last one we're doing in short term is the construction schedule model. And more or less this is an aggregate of all the different models put together into a single model, plus we add some scheduling. And some of the challenges here are that we are entering new territory where IFC hasn't gone before. So we have things like pour breaks and pours, and there's been no history in IFC of trying to encapsulate that type of information before. We have formwork shoring. There's a similar situation there. We also need to figure out how to get the right level of schedule information. We don't want to turn the exchange model into Primavera, but we need to have enough information in there that we can use to coordinate what happens on the site in a 4D schedule. So you say we only have 3 out of 24 exchanges. That's not very impressive. Fortunately, those 3 exchanges cover quite a bit of the information space. So we feel that the people in the industry will probably use these exchanges in other parts or other situations in the industry, even though they were not designed specifically for those situations, and will get some good productivity out of those. And of course, we're focusing on the exchanges that we thought had the highest value for the industry. And we want to get something out the door as soon as we can. We could try to do all the 24 exchanges, but we'd probably be here another 10 years, and maybe the industry would have moved on by then. So the current status for us is that the IDM is out the door. You can get it at the bookstore, as I mentioned before. And we're working on the MVD, those detailed definitions. The MVD group has been meeting at the conventions all day on Saturday for the past couple years. It's an impressive set of industry experts here, plus Chuck, our consultant. And a little comment on how easy or difficult this MVD stuff is. Where IFC contains the concepts we need, it's not too difficult. It's work, and that's why we've been meeting for a long period of time. But where IFC doesn't have the concepts we needed, it is quite difficult, and we're kind of breaking new trails there. We're a little worried about building smart as being another approval bureaucracy. We're going to need to go through an ACI approval and also a building smart approval. But we've made a lot of progress, even just this convention, and we're hoping to get ballot starting in the fall and maybe get the thing through in about 12 months. So that's all I had, introduction. Any questions?